Execute retinal scan. Access granted.
Step by step, fill in electron and MO energy level diagram for the following compounds and determine if it's low or high spin and explain why. To draw a molecular orbital energy level diagram, we need to fill in the electrons first. The first step is to determine the oxidation state of the metal. Then, using the oxidation state, we have to figure out the valence electron configuration. Then the d orbital system for bonding needs to be figured out. Using that, we can figure out the number of electrons contributed from metal. Then, we have to calculate the number of electrons contributed from ligand. In the end, the total electrons involved, which is the electrons from metal and ligand, is calculated. First, we are going to take a look at hexafluorocopylate 3 ion. Here are the steps to fill the electrons in molecular orbital. This is the molecular orbital energy level diagram for this compound. Next, we are going to take a look at Penta-Amine Aqua Cobalt 3 ion. Below are the steps to fill electrons for this compound in molecular orbital. Molecular orbital energy level diagram for this compound.
Next, we are going to look at cobalt trichloride triammonia. Here are the steps to fill the electrons in molecular orbitals.
This is the molecular orbital energy level diagram for this compound.
And lastly, we are going to look at molybdenum hexacarbonyl. Just like the other compounds, these are the steps.
Molecular orbital energy level diagram for this compound.
Now, let me describe and give an example of MO energy level diagram showing metal ligand charge transfer (MLCT) transition, and give an example of MLCT in catalysis application. Metal to ligand charge transfer (MLCT). It is a transition that the electronic charge shifts from the molecular orbital with a metal-like character to the ligand-like one. It occurs when the metal is in a low oxidation state, electron-rich, and the ligand has vacant pi star orbitals, for example, CO or Cn negative molecule. It results in the oxidation of the metal. One of the examples of MLCT compounds is ferrocyanides. The catalysis application of ferrocyanides is as precursors to the Prussian blue pigment. It combines with sodium to become sodium ferrocyanide, which is a common anti-caking agent and precipitating agent for the production of citric acid and wine. The slide shows the MO energy level diagram of ferrocyanides. MLC3 transition occurs from T2G orbitals to the pi star orbitals.
Today's mission. Describe and give an example of MO energy level diagram showing ligand metal charge transfer (LMCT) transition. Give an example of LMCT in catalysis application. Ligand metal charge transfer (LMCT). The transition that the electronic charge shifts from the molecular orbital with a ligand-like character to the metal-like one occurs when the metal is in a rich oxidation state, electron pool and the ligand has full sigma orbitals, results in the reduction of the metal. The energy of separation between T2G and A*, which is delta octahedral, is lower in LMCT compared to MLCT. Dichromates. The charge transfer from oxygen ligands to empty the orbitals of metal chromium gives it the color orange. This charge transfer absorbs greenish blue and leaves orange as observed color. The catalysis application of dichromates is oxidized alcohol, therefore is used as the oxidizing agent in an organic chemistry. It is also widely used in leather tanning, photographic processing, and cement and wood staining. Diagram 2. MO diagram of dichromates.
End of presentation. Execute retinal scan.